Hey everyone, and welcome. Today we're going to pull back the curtain and take a virtual tour of the modern factory. We're going to dive deep into the very backbone of pretty much every single product you own, the automated production line. So let's get right into it. So have you ever just stopped and wondered, how does a company make millions of phones or cars or soda cans and have every single one come out perfect day after day? Well, the answer isn't just a bunch of cool robots. No, it's this incredible symphony of engineering, data, and control working in perfect harmony. And that right there, that's the core puzzle that automation really solves. All right, here is our game plan. We're going to start with the basic blueprint of an automated line. Then, we'll explore what I like to call its nervous system. After that, we'll see how these lines get tailored for totally different products, understand their huge impact on the industry, and finally, we'll peek into the factory of the future. Okay, first things first. Let's really nail down the fundamentals. What in the world is an automated production line anyway? So, at its heart, an automated line isn't just one giant machine. It's really a chain of interconnected stations. Things like robotic arms, smart conveyors, all that stuff that do their jobs with very little human help. But the real magic, the secret sauce, is in those control layers. That's the integrated brain making sure every single little movement is perfectly timed and synchronized. To really wrap your head around those control layers, it helps to think of the entire factory as like a living, breathing organism. It has a brain, and it has this super complex nervous system that coordinates every single twitch and movement. So here's how that nervous system is built. At the very bottom, you've got the PLC, the programmable logic controller. Think of these as the nerves, the reflexes, telling an individual robotic arm exactly how to move. Then a level up, you have systems like SCADA. They act like a brainstem, coordinating a whole group of robots for one specific complex job. And then way up at the top is the MES, the manufacturing execution system. This is the conscious brain, the CEO overseeing the entire factory. This three-tier system is the industry standard, and it's how you make sure a tiny movement from a single robot perfectly aligns with a company's billion-dollar production goals. And just like any living thing, this system needs senses. How does it know what's going on? Well, through a whole array of amazing sensors. Position encoders know the exact location of every part, down to the millimeter. Force sensors can literally feel how tightly a machine is gripping something. Vision cameras are the eyes, constantly checking for quality. And get this, vibration monitors listen to a machine's hum, like a doctor listening to a heartbeat. If that rhythm changes even slightly, it signals a problem long before a total breakdown. That's something called predictive maintenance, and it's a total game changer. All right, now it probably goes without saying, but a factory that churns out 1 million identical sodas every single day is going to look way different from one that builds customized cars, right? The actual design of the production line, its architecture, has to be a perfect match for the product. Yeah, this is all about choosing the right tool for the right job. Think of it like a train system. A single model line, that's your high-speed bullet train on a dedicated track. It's unbelievably fast for that one product, but it has zero flexibility. A batch line is more like a freight train, stopping at the station to completely swap out its cargo for the next big run. And the mixed model line, that's a bustling city metro system with all sorts of different trains zipping off to countless destinations at once. It's maximum flexibility, perfect for customer orders. So these systems are without a doubt the engines of our modern world. But putting them in place involves some really big decisions and, you guessed it, some very clear trade-offs. And this brings us to the classic trade-off in automation. On the one hand, these traditional lines give you absolutely incredible speed and rock-solid, consistent quality. The gains are just massive. But the price you pay for all that is often flexibility. It can be insanely difficult and expensive to retool one of these high-speed lines to make something new. And as you can imagine, this trade-off creates a pretty big divide. Huge corporations can afford to pour massive investments into these dedicated high-speed lines. But for small and medium-sized businesses, it's a whole different ballgame. They're dealing with tight budgets and the very real challenge of training their staff on these super complex new systems. For them, a slow, careful, staged approach is often the only way to make it work. So where is all this tech headed? What's the next chapter in the story? Well, the next evolution is already underway, and it's all about making automation smarter and way more flexible than ever before. The key to this future is something called the digital twin. Now imagine creating a perfect virtual replica of your entire factory right inside a computer.
Before you even think about spending a single dollar on real equipment, you can test, debug, and optimize the whole line in a simulation. This just crushes costs and development time. It's the technology that's starting to solve that old trade-off between speed and flexibility, and it could unlock mass customization on a scale we've never seen before.
And that brings us to our final thought. As these production lines get more intelligent, more aware, more self-sufficient, as they go from simple automation to true autonomy, it really forces us to ask a pretty profound question. In a factory that can basically run itself, what's the future role for us?